in this video, we're going to look at the concept of bearing. So bearing is a way that we can talk about navigation on the surface of the Earth. And this would be an angle measured from due north in a clockwise direction. That is the direction that heads towards east first. So if I'm considering a bearing of 120 degrees, for example, if the origin is representing a starting position, then we consider the orientation towards due north as our 0. And if we rotate 120 degrees clockwise from that position, we would end up in the quadrant between east and south on a bearing of 120 degrees. Now, it is possible to compare bearings to other things other than just north. For example, I could talk about this as being 30 degrees off of east, or it could be considered to be 60 degrees east of south. 30 degrees south of east or 60 degrees east of south. But the most common would be to say that it's a bearing of 120 degrees. We can also compare bearings to each other, which we'll do in an example a little later. So considering a bearing of 315 degrees, again, if 0 is the north and we must work in a clockwise direction, 315 would put us almost all the way back at north in the second quadrant between north and west. So again, we could call this is a bearing of 315 degrees. It could also be called 45 degrees north of west, or in fact, it could be called 45 degrees west of north because it's exactly halfway between the two. That's a perfectly northwesterly bearing. But in terms of just giving a single bearing, it's 315 degrees. So let's consider a problem where we're comparing two boats. So we have one boat leaving a port on a bearing of 85 degrees. So if this is the port, and I want a bearing of 85 degrees, I need to first consider where is north. So if this is north, 85 degrees will be 85 degrees east of that because we're always rotating in an easterly direction. So this is 85 degrees. Now note that I have a 0 in front of it. Bearings are always given as 3 digits. Even if it's only a 1 or 2 digit angle measure, we'll just put zeros in to fill it in. So this boat is heading in that direction at 12 kilometers per hour. We have another boat leaving the same port. Okay, so that's handy, so we can use the same north line. This time on a bearing of 123 degrees. So 123 is going to put him kind of in that direction. He's going a little slower, so I'm not going to draw that line quite as far. So that's 8 kilometers per hour. And that's a bearing of 123 degrees. I want to know after 2 hours, what is the distance between the boats? So let's say this was the 2-hour point. If that's the 2-hour mark, I'm looking for this distance, x. And I know that in 2 hours, the first boat has traveled 24 kilometers and the second boat has traveled 16 kilometers. So if I want to find the distance between them, I could use the cosine law if I know the angle between them. Well, I do know the angle between them because it's the difference between their two bearings. In other words, 123 degrees minus 85 degrees. So the angle between their two bearings is 38 degrees. Knowing that, I can now use the cosine law. X squared is going to be 24 squared plus 16 squared minus 2 times 24 times 16 times the cosine of 38 degrees, all of which comes out to be roughly 226-ish 0.8. That's x squared. So when I take the square root of that, I get that x is approximately 15.1 kilometers. So these two boats, after 2 hours, are about 15.1 kilometers apart.